This project is perfect for anyone who wants to work at the intersection of computer vision and real-world industrial automation. Because assembly line quality control is one of the biggest and fastest-growing applications of AI today. Think about how products move through a production line at incredible speed. Humans simply cannot inspect hundreds of items per minute with consistency. This is where AI steps in and delivers stable, high-accuracy inspection at industrial scale. In this project, you build a system that can detect surface scratches, dents, missing components, color mismatches, dimensional variations, and even label misalignment. These problems sound simple, but solving them in real time under varying lighting, camera angles, and conveyor speeds is a true engineering challenge, which is exactly why recruiters value this skill set. Companies rely on AI systems to catch defects that manual inspection often misses, and studies show that automated systems achieve up to 99% accuracy. This not only reduces warranty claims, but also improves customer satisfaction and boosts productivity across automotive, electronics, pharmaceuticals, textiles, and consumer goods manufacturing. By mastering this domain, you position yourself for strong industrial AI roles, because factories worldwide are rapidly modernizing. To build a professional-grade quality control system, you need a blend of computer vision fundamentals, deep learning expertise, and practical industrial deployment knowledge. You start by learning how to detect and classify visual defects, segment damaged regions, and recognize anomalies that occur rarely but cause major manufacturing losses. You also learn how to handle challenging production conditions, such as variable lighting, high-speed motion blur, and objects appearing at multiple scales. On the deep learning side, you use models like YOLOV8 or EfficientDet detection, UNET or mask RCNN for segmentation, and ResNet or EfficientNet for classification tasks. For anomaly detection, autoencoders and SSIM-based approaches are common, especially when you have limited defective samples. You will also rely heavily on transfer learning, because industrial datasets can be small. Then comes real-world integration. You connect your model with industrial cameras, calibrate the imaging setup, deploy inference on edge devices, and integrate with PLC or SCADA systems that control the production line. Recruiters love candidates who understand this end-to-end pipeline because it proves you can build solutions that survive real factory conditions. When you start implementing this system, you begin by collecting thousands of images directly from the production line, because real-world data is the foundation of high-accuracy inspection. You label samples as normal or defective, and also use datasets like NVT-ECAD to bootstrap early experiments. In weeks 4 and 5, you train models tailored to defect type. For surface issues, segmentation models like UNet work well. For missing parts or misassembled items, object detection models are ideal. Your target is achieving extremely high precision, so the system avoids unnecessary rejections. Once your model is ready, week 6 focuses on speed optimization. You use techniques such as model quantization, TensorRT, and ONNX runtime to achieve ultra-fast inference, ideally under 50 milliseconds, because factory conveyor belts do not wait for slow models. In weeks 7 and 8, you deploy the system on industrial PCs or edge GPUs and integrate it with reject mechanisms and dashboards that show defect rates and throughput. In the final stage, you run real production pilots, compare system performance with human inspectors, measure ROI, and iterate to match manufacturing standards. Building an AI quality control system opens the door to some of the highest demand roles in industrial AI because companies everywhere are under pressure to reduce defects and increase production speed. You can become a quality control AI engineer, an industrial computer vision specialist, a manufacturing ML engineer, an automation vision engineer, or a quality assurance data scientist. Recruiters look for people who understand manufacturing constraints, can handle hardware-software integration, and can build high-accuracy, low-latency models that run on edge devices. Adding portfolio keywords such as defect detection, real-time inference, UNet, YOLO F8, industrial vision, and anomaly detection will significantly boost your visibility. Leading companies like Foxconn, Bosch, Siemens, ABB Robotics, Keyence, and Landing AI actively hire for these skills. Salaries range from 9 to 18 LPA in India and $95 to $170,000 globally, especially for engineers who can deploy models in real factories. This project gives you a strong competitive advantage because you demonstrate real industrial impact rather than just theoretical knowledge. Start building this today and put it on GitHub.